Hi, I'm Andrew Armstrong and welcome to the Back Office Teardown Lab. I'm testing this today. Well, I say testing, it's more of a teardown. I have been testing these. You could get these lights that go on your shoelaces so that if you go running, every time you do a stomp on your foot, they flash. So it's kind of cool for running in the winter and at night. And these have been on my runners, my trainers, kind of like all year. One of them's still on and the other one, this one rather, has fallen off. And you can see it's just sheared from stress. But it does have this nice little feature, doesn't it? Where it is just kind of on all the time and then flashes. But when you hit it, you can hear like a little, maybe I imagine I can hear a little springing sound. So I was kind of curious as to what's inside one. Ah! Off it goes. There are no user serviceable parts in this apparently, and it's Marks and Spencer's. So I'm guessing it was one of those things that you get as a seasonal gift for somebody, because I'm not sure Marks and Sparks are known for their running equipment. So just prodding with my scalpel here, and it's really not got enough force to lever that open, which is kind of disturbing. So I'm wondering if to soften this up with a bit more of a heavy duty tool, such as some pliers. So I'm just going to get in there. I'm just going to kind of crunch around it. I think that's the technical term, crunching around. It is tough though. To be fair to it, it is bloody tough. Still works. Doesn't quite work now anymore. Oh no, it does. Good. It's just really loose because the battery bay's now been discombobulated. So the battery snap contact is actually on the lid, which is now broken, which kind of sucks. So wow, it is actually lithium cells. So it's two CR120s. Sorry, one 220s. Sorry. Interesting. So they're kind of a fancy schmancy cell. I thought they were going to be just the regular ones that you used to get in like your Game & Watch, whatever those ones are called. I think they're called an AG13, depending on where you're from. Ooh, so let's see though what we've got going on here. Focus. So there's our little PCB. It's a diddy one. So you've got two LEDs, and each LED has 3 LEDs in it, if that makes any sense to you. So it's actually a cluster of LEDs. So you have a J3Y, which is an NPN transistor right there. And then you've got this R1 and R2s, which are omitted. And then there's just a little resistor and a capacitor. So I think it might be worth trying to just put some power onto this thing and seeing how it was playing around. Unfortunately, I'm not sure which way round these batteries were. They kind of look like they could have been the same way around, but that would be utter madness. So let's get our bench power supply, which is over here, and we'll get ready. So I'm going to put the bench power supply on. How many volts is this? So it's 6 volts. So I'm hoping with a little dab it won't break, and I've just going to show you. I'm fixing my wire here. I'm so wire starved that I've not prepared my wire in advance for you guys. Just going to be doing a tiny bit of solder here. I kind of mashed up these clips, these probe clips, so I'm just kind of soldering to them now. It's all a bit jury-rigged. So while I'm doing that, I'm just going to speculate. That thing in the middle, though, it looks kind of like a crystal, but I think it could be basically a sensor. It could be something in a can. Hopefully not a blob of mercury if we choose to open it up and have a look. So there is our power now. Let's get that over there. So I've got 6 volts running. So one battery contact goes to one leg of this gadget, and the other goes to this wire, but there is a V minus there, and that may well indeed make contact. So I'm just going to get my continuity meter. It's a lot of effort, isn't it, for this little thing, but it is a bit of fun. It's better than throwing it away, isn't it? Yeah, cool. That's what I thought. So I'm just going to go for random, be honest with you. Let's hook this onto here. Or not. It's almost too wee. So we didn't get anything that way. Actually, it does say V minus. I can see V minus there on that test point. Definitely put it in the wrong way around. Come on. Come on. I suspect we're going to need a better connection here. LED pulse. Hey, there we go. Well, crikey, that was bright. I suspect the batteries were running out. I might actually be blind now. Right, so we've got it connected. Holy smokes. That is blinding. I'm actually looking at it in the camera now because it's too blinding. So there's our transistor. I kind of thought maybe our transistor would be a bit so whatever's going on in that, it is definitely acting like a switch. I guess it's kind of probably a vibratory, some sort of switch. Well, as fun as this is, I think it's worth having a look inside here. Oh, my eyeballs. So I'm going to speculate, though, that the whole other gubbins there with the transistor and the capacitor and stuff is just for it to linger a bit. Ah, dang, that's hot. Woo! Yee-hee! That is toasty. Toasty marshmallowy. Doesn't say here what that thing is, it just says it's a K1. So it's a K1. So should we put our, let's, for a bit of fun then, let's see if we can put our meter on this. We've got our continuity going. So it's the can. It's just the can and a center pin. That's kind of what this circuit would be. The problem we have there is, how do you tap the bloody thing while you're... Oh, the end fell off. Hang on, maybe there was never an end on it, but I can show you how it works now. We know how it works. Fantastical. Look, it's a spring. When you run, the little spring just hits the sides. That's sweet. Now let's see if we can use some technology to have a closer look. That is kind of insano. Right, stay there. I'm just going to get out our gadget, the mystery gadget that I've revealed to you in an earlier video, and I intend to do a video on it at some point, but not today. I keep saying that, don't I? Not today. Welcome. Where are we? There we go. There you go, so you can see, there's your spring. And I know that video looks a bit odd because we got a camera looking at another screen here. But yeah, you can definitely see there's springiness there going on. So what happens is, when you hit that, the edge of that spring basically touches the edge of the can and it makes a circuit. But it'll only make it for a fraction of a second, like crazy fast, probably too fast really, for the thing to dwell long enough, for the LEDs to dwell long enough, but also with barely, it'll barely be able to transmit enough current in that sort of fraction of a second. So that's why it's there, that's why you've got the other components. But that's quite a nice design, isn't it? You could easily make something like that yourself. Ow! Shoo! 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 That's why it gets so hot, by the way, when you're soldering it. It's not like a semiconductor. It's like the can is the contact here. So I don't know what to do with this now. We've just discombobulated it. We've we've looked at its batteries. I think I'll throw away these cells though into the recycling bin because they are no good. I say that, recycling bin, into the battery bin. No, you mustn't throw those into the recycling bin. Let's see if this thing still works. So there's other benefits of this, of course. It does mean, can aside, we might be able to actually get this to trigger on something else that could be interesting. Let me have a root around. We'll have a quick experiment with something else. Okay, I've got my little experiment here set up, and you can see something else is activating the light here. Right, I'm going to put my finger here actually on that so you can see what I've got going on. I've got a piezo speaker. So that's something you probably didn't realize, but now you do. It's kind of funky actually. Piezo speakers. You can buy very, very, very expensive aluminium push switches that look like buttons, and they've got like a glowing LED ring and all sorts. They're like really industrial buttons, and they're mega expensive. They've got a patent on the technology, and I basically made my own variant of those with this a long time back. So you can get these piezo speakers of any size, and they've got this property that when you flex them, they make a tiny bit of current. And look what happens when you attach something that makes a bit of voltage and a bit of current onto the base of a transistor. That's of course the transistor fires. So you've got something that will operate quite nicely. You can do the tinging, ting tang. Probably not as nice as that thing though, because that's a big old good connection. That's putting probably, depending on the resistor, that's probably putting a very healthy voltage into the base and switching that transistor hard. The piezo, it's variable. You can see it as I do it gentle. It's very gentle. It's not like this where it's just closing a circuit. It's varying. But if you hit it, you know, it can detect all sorts of things. So you could use it for, like, you know, when you get a knock detector on your engine or something, that's kind of sensors. That's all they are really. And they count as like an ultrasonic, I believe, sensor. So you could probably fire something into that's at that frequency and it would flash. So all sorts. I don't know if it can work off the voicey voice. You can try that real quick. I'll put my how do we do this? Hello. No, it doesn't like that. It would need something mechanical to hold this, so it sort of could vibrate properly like as a cone. But there you go. So that's a nice pressure switch though, really. If you want something that's going to operate as a pressure switch, you'd have to mount it between some pivots or something so it can flex, but you don't want it to flex too much, so be a bit wary of that. I mean, let's just have a quick experiment really to see how you could do it. I mean, you can see it there. In fact, that's probably, yeah, so if you had that there, and then underneath that we put like this scalpel blade, so it's going to pivot on there, so it's got a little fulcrum. There you go, look. You've made your own flexi light. So there. Hopefully that's been of some interest to you. It's certainly been of some interest to me, and it's kind of groovy. I feel, oh, broke it now. I feel that this is something that I might make some sort of use of in the future, just as a project really. But that's kind of cute too. Have a think about that. How can we do something interesting with this technology? As ever, thank you, my chums, for watching.